Okay, so in April 1906, there was a massive earthquake and it hit San Francisco. It damaged a wide area of Northern California. But on that day, Wells Fargo Bank, it started out as any other day, pretty normal, but fires soon broke out and forced the staff to exit the building. The staff left without any stationery, any books, and no customer records. Anything that remained was locked up in vaults, not the same vault, that would be too hot to be opened for weeks, days to come. So without anything to do with that then, they had their, sure, sorry. Oh, thanks. They didn't have their account ledger books, so tellers had to go work from memory. They had to perform all their transactions, and they had to record customer withdrawals in school composition books because they had no other paper available. 6 weeks later, when Wells Fargo was able to resume operations, those emergency transactions were finally reconciled. Amazingly, the bank's books balanced to within a few dollars. But obviously, in today's world, that doesn't scale. And people alone are not going to be able to get us there. So today, hence the delay, I'll get the hang of it. So it's a pleasure to be here this afternoon. And a big thank you to the HashiCorp team for hosting the event. My name is Naomi Howard, and today I'm going to cover operational resilience. We're going to start with what is operational resilience, a little bit on AWS's approach, and then how we help our customers in this space. So what do we mean when we say resilience? Resilience is really the ability for a system to operate, to continue to operate during failure, where that failure may be induced by load, attacks, or any other failure. And it's to be able to return to operations quickly within the boundaries and the targets that you define as part of your business continuity procedures. So from an operational resilience standpoint, we extend on this definition of resilience to focus on the continuity of key operations across your enterprise. And at AWS, we define operational resilience as the ability to continuously service through its people, process, and technology that are aware of and adaptive to constant change. So within this definition, we typically focus on 4 key pillars. So we've got observability, high availability, disaster recovery, and supplier contingency. Observability being the ability to continuously monitor and measure in order to understand normal operations. And when we talk about high availability, we're talking about being able to design and operate our systems to ensure they are immune to common failures. Disaster recovery is the ability for the system to return to normal operations. And that's within your predefined targets. And then lastly, we look at supplier contingency and your associated portability plans. But when we consider all of these pillars, it's really important for us to consider the notion of continuous resilience. This is not a set and forget mindset. You can't just hope that it will work as you expect when the time comes. You got to do it continuously. So the idea is that you will test early, you'll test often, and you'll test both across your technology stack and your teams to ensure that they're prepared to respond in the case of failure. So if we look at operational resilience through the lens of the financial sector, this is to prevent, adapt, recover, and learn from operational disruptions. And across the globe, we're seeing a really big increase in the number of cyber incidents and a growing number of high-profile service outages. And this is forcing the regulators to increase their focus on operational resilience, and that's including third-party oversight. And that's in their efforts to protect the financial system, but it's also to protect the customers of the financial system. And we're all too aware of some of the stories that have placed institutions into the newspapers for the wrong reasons. Only last year, there was a story of an Irish bank that allowed customers to withdraw money that they didn't have. And at AWS, we recognize that our financial services customers, you need to be able to comply sector-specific regulatory obligations, but also you've got internal requirements regarding operational resilience. And we are working closely with our local customers, especially as we see policy changes with CPS 230 due to come into effect next year. So it goes without saying, for a high-stakes sector such as financial services, the notion of operational resilience essentially equates to financial resilience. And it's the associated trust and confidence that consumers have in the financial system. And delay. So how do we, is it this one? Yep. Do I keep abreast? What's that? Oh, that's gone. Okay, so how do we translate operational resilience for a financial institution in a way that makes sense? And how do we actually define in data whether we're actually going to meet those needs? So in simple terms, our goal is twofold. One, prevent customer harm, and two, to not impact the financial stability of the system. And with this in mind, we begin coming up with our operational resilience plan. And that's by working through different plausible scenarios and assessing against our defined tolerance impact levels. So as you can see in this graph, often our plans will start with those key service level agreements. And this might include agreements on your targets, such as your recovery point objective. So how much data can you afford to recreate or lose? Or your recovery time objective, how quickly must you recover? And above this is our continuity, business continuity plan. And that forms the last line of defense before things go towards customer harm and financial instability. So in a world where there is no such thing as business as usual, when we start planning for resilience, what are some of those plausible scenarios? So in reality, there's a large number of factors that can cause instability in the financial sector. So these could include some of these examples here. Delays in receiving timely, fast account updates. Factors such as a fire or a flood that might negatively impact your data center, where you might have the need to exit your people or your applications very quickly. You may have trading or clearing functions that are not operating as expected or meeting under stress requirements. But it's also important to look at external factors, and they may include malicious intent. We may have things like a distributed denial of service attack, which would require more enhanced DDoS protection, or a cyber attack, resulting in the use of a cyber vault to be able to recover your data and systems. So with all of this, where does an organization start? And if we're looking to modernize and migrate their key systems to the cloud, how do they ensure that their applications are resilient? Well, it all starts with a mindset and a recognition of some home truths. Our CTO, Werner Vogel, he has an insistent reminder that everything fails all of the time. And he has said that failure is part of any reasonably complex system. And that will include data centers, distributed software systems. And one of the good tenets of application design is to be able to design for failure. Resilient applications will provide continuous service despite that natural disaster, or despite disasters, whether it's a natural disaster, a hardware failure, or some kind of human failure. And at AWS, we do embrace those potential failures and build systems that work and are highly resilient despite those failures, and we encourage our customers to build for failure also. And so, at AWS, our customers share a common interest in maintaining operational resilience. And we differentiate the responsibility of resilience of the cloud versus resilience in the cloud. in this model, if you can see, so AWS is responsible for ensuring that the services used by our customers, so basically the building blocks of your applications, that they're continuously available, as well as ensuring that we're prepared to handle a wide range of events that could affect our infrastructure. So while our customers retain control of the resiliency they choose to implement with access to AWS tools and services to meet their resiliency objectives, they design workloads to be resilient in the cloud. Achieving reliability, look, it can be challenging from experience in a traditional on-prem environment, but at AWS we can build workloads that have strong foundations, they have a resilient architecture, consistent change management, and proven failure recovery processes. So how do we achieve this on behalf of our customers? So it all starts at the lowest level of the AWS cloud infrastructure, and it's to ensure that it's designed to meet our compliance, security, and resiliency requirements. Our regions are a physical location in the world where we have multiple availability zones or AZs, and an AZ will consist of one or more discrete data centers. Each will have redundant power, networking, and connectivity, and they're housed in separate facilities. They exist on isolated fault lines, floodplains, and the networks and electrical grids are separate, and that substantially reduces the chance of simultaneous failure. AZs offer AWS customers an easier way and a more effective way to design and operate your applications and your databases. We do this in a way to make them more highly available, fault tolerant, and more scalable than traditional approaches. And using this model, we serve millions of customers in more than 245 countries and territories, and we have more to come. And then underpinning these regions and AZs, we have designed and built a global network. And that provides our customers with a reliable and private connections to their on-prem environment. So while in transit, that network traffic will remain on the AWS global network, and it never touches the public internet. And that substantially reduces the chance of hitting bottlenecks or unexpected increases in latency. This design provides resiliency against device connectivity and complete location failures. But resilience goes beyond our region and network topology. It also spans into how we design our architect our services. And we use a very simple philosophy where we design services to minimize customer disruption when failures occur. To do that, so to minimize the impact of an AZ impairment, each service in one region is isolated from the same service in another region. Essentially, it's a shared nothing architecture. And services are designed to use multiple AZs, just as we advise our customers to build their own applications. And then we leverage separate control and data planes. So AWS will decouple the data plane from the control plane. The control plane being the administrative part of the service. So for example, you might want to separate the storage of your data in a database from the process of actually deleting that database. So our services are built using a cellular architecture, and this borrows from the design from shipping, where like bulkheads on a ship, services are further subdivided into smaller cells that are designed to fail independently. And when we continue to innovate, and we do continue to innovate through areas like shuffle sharding, which is really complex maths for me anyhow. And one example of that is Route 53, and that's where we minimize single points of failure. So while all this clever design and technology help, we do recognize that continuous service is through the effective use of our people, our process, and our technology together. So in support of this is our culture. And some of the ways of working that we employ include a service ownership model. And that incentivizes our teams to continuously improve their operations. So we've organized our engineering teams and our product management teams efforts. So they lead them as like small multidisciplinary teams, and they've got a really strong sense of ownership of the services that they build, that they own, that they run and operate and support. And we have, each time we do a comprehensive readiness review, and that will ensure that all new services, they meet that operational readiness. We'll have like a launch team that will follow best practices. They'll have a standardized run book to ensure that the service meets the bar. We also use a safe continuous deployment pipelines, and that's to minimize the potential impact on production caused by any maybe faulty deployments. So for example, on that one, we'll have like an AWS service. It'll start out small. We'll release it to a single server on a single AZ, and then we'll wait and make sure it's all operating as expected, and then we'll roll out to multiple AZs, and then we'll roll out to a region, and so on to the rest of the regions. If any issues do occur, we'll leverage an incident response mechanism, and we call that a correction of error process. And that helps our teams understand what was the root cause, where did we go wrong, before making sure we resolve it and make sure we fix across all services. If we then dig a little bit deeper into the way we think about a new service design, we have also baked a high standard of security and compliance into our core service lifecycle. So from initial idea, design, through the security reviews, testing, final approval, we deploy through a rigorous process to bring those new services to life. And we always obviously start with our customer needs and work backwards from that. After deployment and general availability, then we will also make sure we're continually performing penetration testing and vulnerability scanning. So while this is not a complete rundown of everything we do, hopefully it gives you a taste of the lengths that we do go to as part of the shared responsibility model, and especially when it comes to resiliency of the cloud. So next we're going to look at the options available to our customers as they look to drive resilience in the cloud. So the first consideration when it comes to defining your business continuity plan is to define your recovery point objective and your recovery time objective. So in other words, what's the maximum acceptable delay between the interruption of service and the restoration of service? And these objectives, they should be set by the organization. They'll be informed by IT, but not necessarily set by IT. So what might that look like, and how do you determine the right strategy for your for a given RPO and RTO? We'll look at this quickly. So we broadly categorize our disaster recovery strategies from low cost, that kind of low complexity approaches, maybe making a backup, to the more complex strategies where you may have regions or active architectures. So your overall DR strategy, it should be determined based on what's the holistic business needs across each of your applications. And I can't stress this enough. It's really imperative that you test your DR strategy so you have the confidence that when you invoke it, when it becomes necessary. And if done correctly, we know that there are clear resilience benefits to financial institutions from cloud adoption. And as regulations continue to evolve, we are committed to making sure we help customers respond to those new rules and guidelines. So what are some of those options that we make available to customers to help you design resilient and reliable workloads? Well, we can help to partner with you to identify your key performance indicators and then support that automatic recovery from failure. So that might include your compute, your databases, your load balancer recovery, essentially whatever you have supporting your core banking app. We also will assist in the testing of those recovery procedures, which isn't always easy to do in an on-prem environment. But with cloud, you can stand up an environment, you can test those plausible scenarios to understand the core banking app, how it's responding under stress. And we can then also help to make sure we understand how to break up those apps. Like how do we break them up into small chunks so that you can scale horizontally? And that will help you to be able to increase and distribute those requests across multiple resources so they don't share common points of failure. By monitoring the demand and workload utilization, you can stop guessing capacity, and that means you can spin up or you can tear down resources as you need without under or over provisioning. And then ideally we're controlling our environment through automation to only launch the resources that meet a certain standard, or you want to revert back to a safe state. Again, this is all very possible and very manageable in the cloud. So one of the key mechanisms we provide to help you design resilient workloads in AWS is AWS Resilience Hub. And this is a central place to help you define, validate, and track the resilience of your applications on AWS. As part of the Resilience Hub, we will provide proactive tools that will help to further ensure your workloads are resilient. And one example of that is the opportunity to uncover potential weaknesses by using AWS Injector Simulator. And that automates the creation of real-world failures. And you can help to validate then the effectiveness of your recovery procedures and your alarms. This service, it can also be part of a chaos engineering approach, which is the discipline of experimenting on a system in order to build confidence in the system's capability to be able to withstand turbulent conditions. So this involves injecting events like, say, things like hardware failures or software failures or any event that's capable of disrupting steady state. The technique, it's a great approach to help your teams build that experience of dealing with planned or unplanned outages that will help to meet your compliance and regulatory requirements. All right, so as mentioned earlier, tools and technologies, they're great enablers, but effective resilience requires a blend across your people, process, and technology. In short, it means putting your strategy to the test. And this includes more than testing your strategy. It means it's also critical to test your people and your process as well. And it's important that customers continuously subject their systems to conditions to be able to build that organizational recovery muscle. And that experience will support these systems during normal and abnormal times. So this is one of the great techniques that we've developed to help build that capability at AWS. It's a game day. And a game day is a collaborative environment. It's a learning exercise. It tests the skills of implementing AWS solutions to solve real-world problems. And it's in a gamified, risk-free environment. It's completely hands-free. It's an opportunity for technical professionals to explore AWS services, architecture patterns, best practices, and it's all through group cooperation. And then following the execution of a game day, we will analyze what did we do, what did we learn, what can we do better. It does come with a word of warning though. Game days, they start out by design, they start out a little hard and they start out pretty scary, but you quickly build up that muscle to get better. The exercise does require high diligence, and it's not impossible, but it is a lot of fun, and the team get really engaged. All right, so a second call out, we've heard this a few times today, I think, is for our extended partner ecosystem, specifically our strategic collaboration with HashiCorp. So some of you will have seen last week, we announced a strategic collaboration agreement that sees AWS and HashiCorp continue to invest in co-developed solutions and customer programs and sales engagement initiatives. So with HashiCorp recognized as a global collaboration partner of the year in 2023, we're really excited to see where this joint agreement takes us. So this will, hopefully, it will help to accelerate our customers' time to value, mitigate implementation risk, and provide a framework to address outcome-driven use cases, especially in the cases of security and compliance. And a great customer story that has come about due to that ongoing collaboration is with a customer called Earnin. Earnin's a financial services company, and they enable its community to access earned wages through a mobile app. And it's had more than 10,000 or 10 million downloads, and they had more than 15,000 resources, and they were all being managed by Earnin CloudOps. The team realized that they needed more than time and talent to be able to scale. And with a significant amount of the team's processes, they were all manual. Everything was done by hand. They would test plans. They would fix issues. They'd pull up command line interfaces. They'd authenticate with AWS, and then they would apply changes. But they were doing that, again, all by hand. They implemented Terraform Enterprise, and that quickly sped up their and eliminated manual pull request reviews, and they increased automation across AWS services such as EKS, EC2, and RDS. And in addition to that, the Earnin CloudOps team, they can now write their Terraform configurations for Terraform Enterprise, and that's just with a few clicks, a few lines of code, and provision those workspaces in minutes. It has, as a result of all of this, the provisioning and operations process, they're now 5 times faster, and it represents a 400% rate of acceleration, which is awesome. I appreciate it's been very difficult to cover such a large topic in 30 minutes. So as I leave you, I wanted to share a brief overview of some of the other resources that are available to you. We have from AWS Well-Architected Framework, AWS CloudTrail, Amazon CloudWatch. You have no shortage of tooling, services, guidance, and amazing support teams that can help you on your resilience journey. I want to thank you for your time. It's been awesome to spend time here today. And again, thank you to the HashiCorp team. So for those that are looking for more on AWS and HashiCorp, how we can support you with operational resilience, we have a QR code on the next slide. Feel free to take a photo, and thank you, and enjoy the rest of your day. Thank you.